Now in this lecture, we will discuss the 8085 microprocessor architecture. Now here you can see it is a 40-pin IC and operated on 5 volts and the maximum frequency is 3 megahertz. These are the few features of 8085. Now this is the architecture. Now in the architecture explanation only, I have explained the pins of, now these are the interrupts and interrupt acknowledgement pins, and these are SID, SOD, and here you can see higher order address bus and here lower order address bus with multiplex with a data bus and power supply pins. Now here you can see all the timing and controls signal timing and control block pins. So all these pins I have explained when I explained the architecture. Once again that we will see in the 8085 pin diagram. Now this is the 8085 pin diagram. Here you can see pin number. So this is a DIP IC, dual in package, means what? Both the sides equally pins are divided. So 1 to 20 are one side, from 21. So now from the bottom it will start from 21 to 40 is another side. So total it is a 40 pin IC. Now in this IC, pin number 40 is the supply plus VCC plus 5 volt supply, and pin number 20 is the ground pins. So now these two are the power supply pins. Now coming to the pin number 12 to pin number 19 is the lower order address bus multiplexed with the data bus. Now coming to the pin number 21 to the 28, these are the higher order address bus. Now address bus is for what purpose? To hold, to carry the address, and the data bus is to hold to carry the data. Now this is about the address and the data bus. Now here if you see, bidirectional is for what? Data bus is multiplexed. Data is a bidirectional and address is the unidirectional. But here data bus is multiplexed. That's why arrow marks are indicated both the sides. Now coming to the pin number 1 and 2. So the X1 and X2 are used to connect the crystal externally to generate the clock. Now already I said that it is operated on the 3 megahertz frequency. So that clock is generated by using these two pins by connecting the external clock crystal. Now reset out is whenever microprocessor is in reset mode, by sending the signal, it can also reset the peripherals which are connected to the microprocessor. Now coming to the SOD and SID, microprocessor can send the data serially and can receive the data serially by using these two pins. Now outside means what? SOD means what? Can send the data to the from the processor to the outside by using SOD, and processor can receive this serial data by using the SID. Now in this you can see SID and SOD. Now here in this SID and SOD, so these two are applied to the serial IO controller. Now this serial IO will convert the serial data into parallel and parallel data into serial. So inside the microprocessor, the data will be transferred in parallel. Now coming to the trap to INTR, these are the 5 interrupts are available in the microprocessor: trap, RST 7.5, 6.5 and 5.5, and INTR. Trap is having the highest priority and INTR having the lowest priority. The priority order is from the top to bottom. Now after receiving the interrupt, the processor will send the acknowledgement signal by using the INTA bar. So this bar indicates what? Active low signal. So it will send the INTA to the peripheral. Now, next one is hold and holder. These two are the DMA controller signals. Now, whenever the DMA need the bus to transfer the data from the IO devices to the memory or vice versa, then at the time DMA will send the request signal to the microprocessor HOLD hold. So after receiving the hold signal, in response to hold, microprocessor will send the hold acknowledgement signal to the DMA, and after that it will hand over the bus to the DMA, and before handovering the bus, it will load the starting address of where it has supposed to transfer the data, starting address and how many number of words and the direction, everything it will load into the DMA, and after that it will hand over the bus. So this is about the DMA connections. Now coming to the clock out. One after generating the clock, this clock is applied to all the blocks of the 8085. For that, this clock out pin is used. Now resetting. To reset the microprocessor by applying signal on this, we can do the 8085. We can make 8085 reset. Now ready. Whenever the IO devices are connected, IO devices are ready to transfer the data. IO devices will send the ready signal to the microprocessor. After receiving the ready signal, now the processor will start transferring the data between data from the IO devices. Next one is IO oblique M bar. Now this is so data transfer should be from the IO devices or memory that can be decided by using the IO oblique M bar. If this pin is equal to 1, the data transfer takes place from the IO devices. If this pin is equal to 0, data transfer takes place from the memory. Now S2, S1 and S0, these two are the status pins. Now S0 and S1. So because we are using two status pins are there, 0, 0, 4 combinations are there, 0, 0, 0, 1, 1, 0 and 1, 1. 0, 0, it will show the, it will give the indication of the halt. So it will, these two status bits gives the status of the 8085. So if these two pins are 0, 0 means what? Processor is in a halt position. If this is 0 and 1 means what? Write operation is taking place. 1, 0, 1, 0 means read operation is taking place, and 1, 1 means what? Fetching is taking place. Now by using these pins, so the processor status can be detected. Now read operation means what? Microprocessor whenever want to read the data, then it will place a 0 on this pin. So if microprocessor want to read the data from the IO devices means what? It will place the 0 on this pin, and also here it will place the 1. So means what? It will select the IO devices and reading operation is taking place. And if microprocessor want to write the data, then it will place the 0 on this write pin. And if it is selecting 1 means it will write the data into the IO devices. If it is selecting 0 means what? It will write the data into the memory. Now coming to the ALE. ALE is address latch enable. It will latch the address and data bus. Now lower order address bus and data bus are multiplexed together. So for first clock pulse, now if this is a machine cycle, what is machine cycle and everything I will explain in the next step. If this is a clock, now for first clock, ALE will be high. So at the time, this bus will be used as a address bus, and after that immediately it will go to low. So whenever this ALE bit is equal to low, then this bus is used as a data bus. So for first clock pulse, if this bus is acts like an address bus, and after that it will act like a data bus depending upon the ALE. Now this ALE is enabled for only one clock, and after that it will be 0. This is about the 8085 pin diagram.